you. Thank you. All right, folks, I'm going to try to keep it interesting and not too long because I know that all of you are hungry and you want the pizza. So without much further ado, let's get started. Just brief slide about me. I'm a director at Hivemind Technologies. We're a data consultancy. And what we do, we build data platforms and GenAI applications. We've got offices in Berlin and London. And yeah, that's us, right? Don't want to bore you too much. So let's get into the thick of it. So today we're going to talk about Agentic GenAI. Oof, that's a lot of buzzwords, right? Of course, everybody's talking about AI. Everybody has a showcase. But this today is about making that work sensibly in the context of data platforms. So we want to use generative AI applications with our data platforms and with streams. So just to triangulate, what's a data platform like of the modern kind so that we just sort of know what we're talking about and at what area what we're looking at. So generally it's about using things like Kafka or Pulsar or any kind of Kafka compatible broker, right? Kafka Connect, using stream processing, be it Spark, Fling, Kafka Streams, or whatever. Using a query engine, Rising Wave, anyone? Really great product, by the way. And Iceberg, or something else like Pymon or Parquet or whatever. But generally, open table formats. That's sort of like the architectural environment we're operating in when we're talking about data platforms. So now we're looking at LLMs. What is the common approach nowadays to GenAI? Okay, I need to somehow use GenAI in my application. The simplest thing is to create a thin wrapper around a general purpose large language model. Okay, so let's take ChatGPT, OpenAI, or Claude, Anthropic, or Google, and we're just going to use a big prompt and ask it to do something. The great thing about this is that there is very little effort involved, and it's quite easy. You just need to build, let's say, an application, and the application connects via HTTP to one of the endpoints. Bob's your uncle. You've got a generative AI application. That's not very efficient. Why? First of all, it's like very expensive. The bigger model you use, the more expensive it gets because you're charged by the token. That's really, really, really impressively expensive when that scales out. The second problem is latency, right? Especially if you're using the larger models, it takes a while until they compute and you get a response. And sometimes it times out. And of course, lastly, this is Europe, so privacy is really important. Compliance is important, GDPR. You don't want to see your stuff leaked out in the open. A couple of years ago, we had that problem of I think it was Samsung. They had wholesale conversations with ChatGPT about proprietary stuff, and then it leaked really bad. Let's try to avoid that. So that's the reason why it may not be the best idea to just use one of those large general purpose endpoints. Now, there's a concept called agentic. And what that actually means is that you're using a large language model that runs in the local scope of your application and you provide it with tools. Now that's actually a smart thing because the large language model can basically determine and execute local tools to do things. Like one simple thing would be to say, okay, I understand that I need to use a vector database, like retrieval augmented generation, and it can basically just query stuff in that vector store. Simple approach. Or it can execute some code in something that we provide as a tool as part of the system prompt. Say, hey, if the prompt that you get or the query that you get from the user asks you to add stuff, well, you can use this calculator, right? So there's the sample question of asking, hey, how many fruit do I get if I add 2 bananas and 5 oranges? Well, it can use a tool, the calculator, to first of all understand that these are fruit, And second of all, I could just basically compute those 2 digits together and execute that with a small calculator tool. It reasons about the execution of this, and it provides the result. Or it can basically look up stuff on the web or whatever. So the agentic approach is essentially mirroring and using a large language model to reason, quote unquote, to basically create an execution plan and use software or code to execute to fulfill the task. That's pretty cool because it's also quite useful for what we want to do. So then there's another thing that came to the fold called Model Context Protocol. So essentially that's a bit turbocharging the agentic approach and providing an approach to agentic applications to query or basically access other systems. If you want, MCP is REST for AI, right? So REST was really cool as a standard for interoperations of different systems with standardized protocol. MCP does the same thing for large language models. So you can basically query an entry large language model. It can register a set of MCP-enabled servers, right? And it can use them as externalized tools within that agentic approach. It's really very handy and makes composing an architecture fairly easy. It's becoming fast with standard. It's not only supported by Anthropic's models now. It's supported by pretty much all major models using MCP. Most of you who are using CodeCloud or Cursor or other development tools will know how easy that is to configure MCP tools. But you can also not only do that on your local machine, you can do that in the context of a data-driven application. So if we tie all of that together, we have the ability to create an application that lives in our landscape, in our data platform, that ties those services and those approaches together. So generally, we can think about a GenAI application as a microservice that has those tools capabilities, can translate user queries to machines using SQL or HTTP calls, and has access to fresh data. And the interesting bit is that it does not necessarily require a user to prompt it. We can basically integrate these microservice applications within a stream with an incoming message from Kafka, for instance, going to an agentic-powered, driven application using tools, a process that happens within the agentic application, and an output that also goes to Kafka. So just generally not a single human being involved in the process, a different type of interaction with a large language model that does not require a chat. So no chat bots here. But there are things to consider when we're running generative AI application of this type, right? So in contrast to traditional applications, when I write, let's say, a Spark program, or I'm writing a microservice in TypeScript, or whatever it is that you want to do, or a Python script, we generally have deterministic behavior, right? So that's why we call it deterministic, because when you run that program with like the same hardware and the same execution context, it will always deliver the same time complexity and the same behavior, runtime behavior, right? Agentic apps are different. They're probabilistic, right? Meaning basically they use statistical outcomes to compute. So they not always behave the same way. The outcomes are not consistent, and they need to be bounded. We need to make sure that we control that runtime behavior and that we factor in that one request can take 100 milliseconds and the other one might just time out or take 5 seconds or 5 minutes or whatever. The runtime behavior is super sensitive to latency, especially when we use more complex models with chain of thought processes, right? Like the big models that basically compute different pathways within a loop, and then evaluate the outcomes of different pathways and then present the results. And specifically, the other problem is model drift. So model drift means that especially when we use publicly hosted models, These can change over time because obviously, let's say the provider will update its model or change versions or change the behavior of the model. It's software after all. And you may not have any control over it. It's a public accessible service after all. And that can drift. So essentially the outcome of a test or an execution may be different over time. You need to factor that in. Lastly, agentic applications work over a larger context. So memory boundaries are an issue, and it is complex to specifically control. And lastly, the big difference between large language models and deterministic programs is they rely heavily on GPUs, and GPUs are expensive, and computational resource usage is a problem. Of course, you'll argue there are some small large language models that are optimized to run on CPUs, and they have their place. But let's say for a lot of let's say tasks that we want to run in GenAI applications, where it's about quote unquote understanding text or processing text or doing some computation based on reasoning, you'll need GPUs, and that's costly. So these are the things that are super important before you go ahead and say, oh, wow, we don't have to code anymore. We just use those MCP tools and lots of GenAI, and I'm going to replace my entire data processing pipeline with 1, 2, 3, 4 agentic applications. And I'm going to get a lot of praise from the C-levels because they can say that they're an AI company now. That's not going to work, and you're probably going to have a big, fat, nasty surprise at the end when you just, at the very latest, when you get the bill from your provider, your cloud provider. So now let's dig into some use cases that work well with generative AI applications. So where you basically don't replace everything with GenAI application, but we basically try to find a combination between deterministic data processing applications and leverage the advantages of GenAI. One pattern is the observer. The observer is essentially an asynchronous component within your stream that is called specifically when some certain heuristics are met, and is basically tasked asynchronously with a specific, let's say, validation, for instance, would be a typical use case. Essentially, you have a data streaming application. It processes each record in that stream coming from Kafka, for instance, does some validation. It says, okay, this record and the adjacent records look fishy. I want this to be cross-validated by my generative AI application. I'm going to take the whole snapshot, the whole fingerprint of that data set. I'm going to pass it on to the generative AI application app, and it's going to do its thing. And it gets that request with a specific prompt. It maybe uses some MCP resources for cross-validation. It generates the results and pipes that result into another pipeline. And at the end, you basically use a continuous query that joins the result of the deterministic application, the data validator, and the output of your agentic application. So you can basically get the full picture. Another example for this would be to say we have partial data and we want to enrich it with, let's say, I don't know, filling some, especially like in customer complaints where you basically just do some text generation around it. Well, you can use this pattern to specifically asynchronously couple the text generation process from the actual data pipeline and collect the results at a later stage with the join query at the end. So typical use cases here, where this characteristics is division of labor. Standard data processors push selected workloads to the agentic ones. All that is asynchronous. It's elastic and decoupled because long-running processes will not stop the line. You can continue to process your data pipelines as before, and the agentic applications do not affect that because it can basically run with their non-deterministic, wacky latency problems, and that will not hurt anyone. And there's back pressure handling. So agents are not designed to handle back pressure, and you, by asynchronously using the observer pattern, you can factor that in. Back pressure is not your issue because the standard pipeline works as before. Typical use cases are like profiling, for instance, where you're basically doing some scoring of inputs, maybe like in finance, where you basically do some scoring of credit card applications or transactions. Fraud detection is another one. Anomaly detection, where you're basically say, I have let's say a window of fishy data and I want this to be analyzed properly. Well, you can pass that on to a combination of classic fraud detection heuristics application that also uses generative AI capabilities to supplement the fraud assessment. Or, as I said earlier, data enrichment generation, where you basically have a core data set and you want to create or generate text around that core data set for further enrichment or usage in other applications. Let's say when we're looking at generating text for human consumption, like contracts or outgoing emails, letters, etc. The other use case that's typical in the data space is assistive agents, right? That's like fairly standard. It's about helping users, non-technical users, and I think this crowd knows this use case very well, where you have people saying, hey, I want to pull a report of X, Y, and Z, and you want to provide that, but that basically requires understanding what the user wants, translating that into a query, writing a job, creating that report, and handing it back to the business user. Well, you can cut on this by using and deploying an assistive agent. An assistive agent will take the user query. The user can just describe what they want, and that will generate a query against your system. Let's say, to loop back into Yingjun's earlier presentation, we could even think about an assistive agent that generates a SQL query that gets executed against Rising Wave, and Rising Wave delivers, we extract a table as a report from that agent, all that completely automated without having to use or ask a developer to create a notebook application in Spark or whatever for that report. And it can also generate text around the report by analyzing the output and generating an explanatory text. So that's actually quite useful also to cut down on, let's say, on all those tasks that are not fun to do as a data engineer or data scientist, and free up some time to do some of the fascinating and fun stuff. So when we're looking at how to build an application, even in our space, there are like simple ways to do that. Apache Flink is one of them. You not necessarily have to build your agents in Flink, but here it's fairly easy because it has good integration. It can generate and integrate the large language model calling functions as RPC or async functions. It allows to integrate with local frameworks, so Llama Index or LangChain. It's actually quite convenient, and in a lot of cases, we think that's really neat to integrate our agentic applications within Flink, because we don't have to necessarily modify the runtime or introduce a lot of tooling. It works out of the box. There's a new project also with Flink, Agentic Flink, which pushes the envelope a bit further and makes it a bit easier also to write agentic applications with Flink. It's really simple. Here's a bit of an example how to integrate like a call to OpenAI ChatGPT within the Flink application. You can label it, create, and integrate that into as a UDF into a Flink SQL command It's really cool, fairly easy. It takes a couple of minutes, and there you are. So tying it together, when we're looking at how that marries into a standard data platform, we can basically create, the standard Kafka stack with Kafka Connect. We've got SAP, Microsoft SQL Server, maybe S3 buckets, and we pipe all of that into our Kafka streams. We use that in our processing layer, and that can be either Rising Wave, for instance, which we at Hivemind recommend for the most of the stuff, because it's really great that you can just generate SQL and do your transformation pipeline just with SQL and use something else for the more complex stuff, for instance, Flink. We land that in Iceberg, and we can use the Iceberg landed data, connect that to our generative AI apps with an MCP server, or connect directly to our platform using Flink's integration tools for MCP applications. So it's fairly easy, and the great advantage of this approach is that you do not need to integrate or add a lot of infrastructure. You can basically build your agentic application within the remit of your standard data platforms and leverage those advantages, that technology for your standard stuff. So that brings us to the end of the presentation. I hope you enjoyed this, and I hope I didn't keep you from that pizza for too long, and I'm happy to take your questions.